Hey there, everybody. Welcome back. We're doing the Jacobian or the multidimensional U sub. This is 14.7 in Anton's 11th edition for Calculus 3. Let's get right into it. So the 3D Jacobian doesn't look much different than the 2D, other than we're upping it to 3D. Oh, that doesn't look very good. But with the wonders of pause, we can fix that right away. So we've got the derivative of x with respect to u, v, and w along the top row of our cross product. We've got the derivative of y with respect to u, v, and w along the middle row, and then derivative of z with respect to u, v, and w along the bottom row. So this is switching from x, y, z to u, v, and w. And so we're going to have our integral will now be, this is the effectively the u sub, this is our Jacobian right here. And we're going to be switching from dv, which was dx, dy, dz, over to du, dv, dw. Let's look at an example. So we're going to use a change of variables for the function xz over the region D, where D is the parallel pipette bounded by the planes y equals x, y equals x plus 2, z equals x, z equals x plus 3, z equals 0, and z equals 4. So we've got y minus x equals 0 and y minus x equals 2, z minus x equals 0 and z minus x equals 3, z equals 0 and z equals 4. These are pairs of parallel planes. There's 3 of them. How do I know they're parallel? Look at the coefficients. Okay. For the top one, we've got -1 for x and 1 for y and 0 for z. For the next one, we got -1 for the x component, 0 for y, and 1 for z. And the bottom one is just 0, 0, 1. So I don't like these, but these planes actually suggest my limits that I'm going to, or my substitutions. I'm going to say u equals y minus x, so then I just have u going from 0 to 2. I'm going to say b equals z minus x, so then I've got b is going from 0 to 3. It's between those 2 planes. And w, it will just be z. And so w is going from 0 to 4, just like z did. So again, we need to have x, y, and z in terms of those. The z one was easy. To find x, I used the v one. Solve for x, I'd have z minus v, but z is w. Same thing for u, this one. I now have something for x and z, or x already. I can solve for y here. So u ends up being y minus w plus v. And solving for y, I get u minus v plus w. Okay, that's just the setup. That's just converting over to the system. Now we need to convert, find our Jacobian. We need to do the integration, stuff like that. But we've got a nice little setup, right? These are all pretty looking. I copied them over to the next page for us. Okay. So my function of x and z is now w minus v times w, because that's my x and z. So w squared minus vw will be my function. My Jacobian, when I do the derivative of these with respect to u, v, and w, I get this matrix right here. We do the determinant, and we get it equals 1. I did the regular follow across the top and do the subderivatives. But little linear tip, you learn this in linear algebra if you don't already know it. This 0, 0, 1 is going to make it so everything but the k component goes away if I go along this row. So what I did is some row swapping. And you'll learn tools like this when you take linear algebra. I can swap rows in a matrix, and it just changes the sign of the determinant. So what I did is I moved that row up to there, and it made it a negative. And then I moved it up again to the top, and it made it positive again. And now I've got 0, 0, 1 going across the top. I don't even need to look at the 0 and 0. I'm just looking at the 1. It's a 2 by 2 matrix right there. So, and I didn't even do the row swaps. I recognized, I did it in my head. I knew there was 2 swaps. It would be positive. This is just showing you what you'll learn in linear. So what does my XZ look like? My Jacobian was just 1, so dx, dy, dz converts directly over to du, dw. And my XZ is now w squared minus vw. We've got our integral w, v, and u. This is actually separable, but I don't want to separate it because I got a minus sign in it. So I worked it out. Pause it if you want to verify you get the same thing. I got 56. See if you get the same thing. That'll be it. We got one more example. Peace.